Okay, so this is what we covered last time. Now we're doing trigonometric equations. And the steps to solve those are isolate the function on one side of the equation, solve for the variable. So here's an example. It's just like algebra, but sine x. Treat it like a variable, get it by itself on one side. And then once you get sine x equals a constant, then you're going to use your unit circle and look where sine x equals the square root of 3 over 2, okay? So sine, this is what you get for the test. It even tells you that the y-coordinate is sine. So square root of 3 over 2 positive here and here. And I'm usually wanting these answers in radians, so that's pi over 3 and 2 pi over 3. And we found that pi over 3 and 2 pi over 3. And then because the period of pi was 2 pi, we added 2 and pi where n is any integer. Okay, because on the test they'll say find all solutions. And that's where you know that you need to say have a n in there. Okay? So another example, and then I showed how you could use the graph calculator to check for your solutions. But you had to set up the window right. So you're allowed to use the calculator, but you need to follow the directions. I want exact answers, and I want you to follow the directions. So I'm already thinking about the test. You guys are too. So solving an equation with a multiple angle, for instance, tangent of 3x equals 1, I don't know. Anyway, so we did a multiple angle, and so what we had to do is, well, if this wasn't by itself on one side, we get it by itself on one side, and then we notice that tangent of pi over 3, because tangent is sine over cosine, I did it over here, is square root of 3. So that means that 2x equals pi over 3. And then you could say 2x equals pi over 3 plus n pi, because the period of tangent is pi. And then I divide through by 2. These are the terms. Okay, and then we had to, this one said to find not all answers, but all the answers between 0 and 2 pi. So we had to let n equal 0, 1, 2, and 3 and solve this. Just plug in 0, 1, 2, and 3. And that's how I got those answers. And that's where we left off last time. So, any questions about that? So the kinds of, the kinds of work that I'm showing on my notes is what you should show on a test. But you will know what the right answer is sometimes from using the calculator. Okay, so another example. Here's sine. Okay. It says sine of x over 3. Dollar side sine function equals 1/2. So if you look at your unit circle, sine is 1/2, because this is square root of 3 over 2, 1/2. Sine is 1/2 at pi over 6. And sine is 1/2 at 5 pi over 6. It's also, here we have minus square root of 3 over 2, 1/2. So, notice the period of the sine function is 2 pi. So, we know that sine of pi over 6 equals 1/2, and also sine of 5 pi over 6 equals 1/2 from using our unit circle. So that means the inside of the sine function, x over 3, will equal pi over 6. And then we're gonna find multiple solutions. So and the period is 2 pi, so it's gonna be plus 2 and pi. But we're not gonna leave it like that. We're gonna have to plug him in a minute. Or because 5 pi over sine of 5 pi over 6 is also a half. We do 5 pi over 6. Oh, x over 3. Sorry. X over 3 equals 5 pi over 6. Plus 2 and pi. So, oh, and then I'm going to multiply 3 by 3. So, I have to multiply each term by 3. So I get, and I could do it in a different color. It's going to be 3 times 3 times 3 times 3 times 3 times. So we get x equals pi over 2 plus 6n pi, or x equals this. You could simplify this. This is 15 over 6, or divide by 3 is 2. 5 pi over 2 plus 6n pi. Okay, now now we want answers between 0 and 2 pi. Well, so you plug in n equals 0 and see what you get. You get x equals pi over 2, and you get x equals 5 pi over 2. That's 2.5 pi. That's not less than 2 pi. So this is not an answer. We can try 1. We could try n equals 1, and you get x equals pi over 2 plus 6 pi. Well, that's way more than 2 pi. And n equals 1 for the other one's going to be way too high, too. So the only answer is pi over 2. So if they ask for all solutions, you would write all this. If they ask for between 0 and 2 pi, you have to find the exact solutions between 0 and 2 pi. And does that make sense? What would the period of sine of x over 3 be? It's the period of regular sine is 2 pi. The period of it's 2 pi over b, where b is a third,
6 pi.
and so that equals 6 pi. So the period of sine of, you don't have to do this part for the test, but it's kind of, why did this work this way? That's why. The period's huge. So there's not going to be many answers for this. Okay, any questions?
What are we actually using the period for in this, or do we not? It's just more to know why.
Why are we using the period right here in this step? We use the period right here. 2 pi.
Oh, gotcha.
2 pi. We use the period on the previous one.
Oh, so if the period was 1, it would just be pi over 6 plus pi in.
Yeah, if the period was just pi,
Okay.
we just, yeah. So that's why it's 2 pi here. That's what we're using the period for. Good question. So on the tangent function, the last example, the period's only pi. So look at the thing I wrote in green here. That's why I added n pi.
I see.
Can you just hold for a second so I can see the little drawing?
What do you want? What do you want to see?
That little, your unit circle.
This right here?
Yeah.
Okay. And I'll take roll. See who's here today? Casey's here. Rodney's here. Roland's here. Tori's here. Brittany's Brady Quillen. Jacob's here. Madison here. Brandon. Tara. Nina. And Ryan. Okay. You guys are doing good at coming to class. Thank you.
We have to.
You do have to come to this class, don't you? I mean, it is hard to understand, so you don't want to miss class. If you do miss class, go to watch Integrity. Okay. All right, so you're solving a trig equation in quadratic form. All right, so I have a note here to try factoring. And if it doesn't factor, you try the where root property. I'm going to write that first. That's usually the quadratic formula. Usually it's going to factor, and or the quadratic formula. I don't think there's any ones on the test that you use the quadratic formula on. So
There's some old skills.
okay. All right, so we're going to solve. Oh my gosh, we have no room. Let's get another sheet of paper up. Light. I don't need any room. Okay. All right. Sorry about that. So, we're gonna solve part A, 4 cosine squared x minus 3 equals 0. I mean, you could make a substitution if it helped you. If you can't deal with the cosine squared, you could you don't have to do it this way. You can let u equal cosine x. And then write 4u squared minus 3 equals 0. And I'm going to use the square root property. So, because this doesn't factor, these aren't perfect, 3 is not a perfect square. I'm going to use the square root property. So to use the square root property, you isolate or get the squared term. I'll write u squared on one side of the equation. So you're going to add the 3. You get 4u squared equals 3. Then you're going to divide by 4. And you get u squared equals 3/4. Now you're going to take the square root of both sides. Square root. And when you take the square root of both sides, you have to remember to add a plus or minus sign. And the square and the square root cancel, so u is plus or minus. And you can separate that radical to be the square root of 3 over the square root of 4. You got to remember your rules there of radicals.
So if you were doing this in cosine x, or cosine squared x, you would no longer have the squared, right? Because we got rid of it on the u.
Okay, we're finding the solution. U is cosine x, so now I've taken the square root of both sides. So right, it's no longer squared.
Okay.
Okay, and I can show you with cosine squared. It's just, I don't know. Okay.
U's easier.
U's easier, I would think. Plus or minus the square root of 3 over 2. And so, but now u, is cosine x. So cosine x equals plus or minus the square root of 3 over 2. Because u is cosine x. So you're right. We're back to the cosine. Now we've solved these kinds of problems before. So it is actually easier to make a substitution to try to factor. I have the filled-in notes I factored without making it. I didn't factor. I used the square root property without a substitution. But in calculus, you do that, these substitutions all the time. Yes?
Why did you do the plus and minus sign again?
Because that's the part you have to remember about is because 3/4 squared will give you, because if you have x squared equals 4, minus 2 squared will give you 4, and 2 squared will give you 4. You have two solutions. So you have to remember the plus or minus sign when you do that. Because there are two solutions. So this is two solutions. Okay, now we solve it like we did the previous one. So I drew a picture of my unit circle, and I also have it, but I'll just draw a little picture. Where is cosine x? Well, this is square root of 3 over 2 and negative square root of 3 over 2. Where are all the places on the unit circle?
Pi over 3.
Right.
Right.
It's pi over 6.
Oh, sorry.
So pi over 6, because it's cosine, which is x.
Oh.
is square root of 3 over 2, 1/2. And it's at 5 pi over 6 and 7 pi over 6 and 11 pi over 6. On all those angles, those 4 angles. And it's not a double angle, it's just cosine x. So these are our solutions between 0 and 2 pi. So x equals pi over 6. It didn't ask for, it didn't ask for solutions, all solutions, and we found all of them between 0 and 2 pi. I mean, you could write the 2n pi, but that'd be, you put 0 in. It'd be more work, I think.
So how do you know if you need to, how do you know which problem's asking for what? Does that make sense?
Yeah. Okay, x equals that. Okay, so this problem said for x between 0 and 2 pi. So you're only looking for solutions between 0 and 2 pi, and we found them all on the unit circle. So we didn't need all solutions. It will say find all solutions, and then you need to do the 2n pi. If you're doing double angles and stuff like that, you still need to do the 2n pi because it was more complicated.
Gotcha.
But this was just a single angle cosine x, and we just read it off the unit circle. All right, so the next example, so I made a substitution in this one too. If you can factor without making a substitution, go ahead, but we're going to let sine x equal u. We have 2u squared minus 3u plus 1 equals 0. We're looking just for solutions between 0 and 2 pi. We're going to factor this factors. The only way 2u squared is going to factor is 2u and u. We have a positive sign here, means the signs and the factors have to be the same. Negative in the middle means they're negatives. And the only way that 1 factors is 1 and 1. 1 times 1 is 1. And you could check that works. So we're going to set 2u minus 1 to 0, or u minus 1 equals 0. Set each factor to 0. You add the 1, 2u equals 1, divide by 2. So u is a half, or u equals 1. So we're going to substitute back that u now is sine x. So we have sine x equals 1/2. And we have sine x equals 1. We're only looking for between 0 and 2 pi. So we can find all those on our unit circle. Although on the filled-in notes I did write out the plus 2n pi stuff, but found out I didn't need it. Okay, so where is sine x equal to 1/2? Did we already figure this out?
Oh, that's going to be pi over 3.
Yeah. Okay. That's going to be at pi over 3. and 5 pi over 3. So for this first one, x is going to be pi over 3 and 5 pi over 3.
Wouldn't it be pi over 6?
Oh, right. Yeah, I messed up. It is pi over 6. I remember sine is y. So, okay. Sine is y. I was totally wrong. Okay. Let's draw the sketch. I like to draw a little sketch. Okay. So sine is y. I gotta remember. So at pi over 6, which we already figured out, and 5 pi over 6. Okay. This is the reference angle, is pi over 6 over here. Sine is a half there. Right. So x equals pi over 6 and 5 pi over 6. And sine x equals 1. Where is sine equal to 1? Up here at pi over
Pi over 4? Oh.
pi over 2. The y coordinate is 1 at pi over 2. We gotta look at the y coordinate. Okay? So x equals pi over 2, and these are the answers. We found them from the unit circle. Okay, so more examples. Are we ready? Use factoring to separate different functions. All right, so this next example, we cannot just divide by sine x because then we would be losing solutions that way. I'm just making a note. We can't divide by sine of x because we would lose solutions. Okay? So we want to get 0 to factor. We're going to factor. And a good thing, you have to get 0 on the right. So we're going to factor. We set to 0 first. So we're going to subtract sine x. And there's no like terms for sine x. I guess on this one I didn't bother. So this is sine x tangent x. I didn't bother letting u equal sine x. Minus sine x equals 0. So there it is. Okay. Sine x and sine x times tangent x are not like terms. If you want to let u equal sine x and v equal tangent x, you can see they're not like terms. But so you're going to factor the sine x out. Sine x leaves you tangent x minus, and when you divide sine x by sine x, you get 1. It's not just 0. Then you're going to set sine x to 0. Set each factor to 0. And tangent x, I can't write, minus 1 to 0. So tangent x equals 1.
If you pull the sine x out, why wouldn't it be sine squared x on the outside?
Okay, because distribute again, and you see that you get exactly that. You're dividing by sine x. Factoring the sine x out doesn't give you two copies of sine x. We have a common factor that we're pulling out.
Sine x tangent x.
We're pulling this out.
Not the same.
And see, check by distributing, you get that back. You should always get that back by distributing. You could think of dividing, you're pulling a sine out and you're dividing each term by sine. So, so that you don't get sine squared out here. So sine x equals 0 or tangent x equals 1. And, you know, if, since we're looking, and we have x's, not double angles or anything, and we're only looking for between 0 and 2 pi, we don't have to write the 2 pi n. If we wrote it, well, first off, let me find where does sine equal 0?
0 and pi.
Right. At 0 and pi, sine is 0. So, for the first one, sine x equals 0. X equals 0 and pi. That's where sine is 0 on the unit circle. Tangent x equals 1. Where is tangent x equal 1? That's where you're dividing sine by, remember tangent is sine divided by cosine.
That's going to be
So,
pi over 4.
right,
5 pi over 4.
right, it's got to be where sine and cosine are equal. When they're equal, you're going to get 1. So the place where sine and cosine are equal are at pi over 4. You put these over each other, you get 1. And at a positive 5 pi over 4, they're both negative. The negatives cancel out, you're going to get 1. So x equals pi over 4, pi over 4. And so those are the answers because we're only looking for between 0 and 2 pi. Any questions? Do you see why tangent is 1 there, pi over 4? All right. Okay. Got another example here. We're going to factor to separate the different functions. This is how we're factoring to separate the functions. We have to separate these functions to solve it. So we're going to set it to 0 by subtracting 3 tangent x. So you get tangent x sine squared x minus 3 tangent x. I wonder if that's a typo. Oh yeah, there's a typo here. Okay, and then and that equals 0. We subtracted the 3 tangent x. It's not like terms with this, so we just subtract it. Now we're going to factor the tangent out. Tangent x sine squared x minus 3. And now we do set both these factors to 0. Continue up here. We get tangent x equals 0. When is tangent gonna be 0 when sine is 0.
Pi, 0,
You can multiply through by cosine, get rid of that. It's where sine is 0. Where sine is 0 is at 0 and pi, right? So x equals 0 and pi. All right, and it's at sine squared minus 3 equals 0. We're going to use the, x. We're going to use the square root property. Sine squared x equals 3. Was there a mistake? Okay, this is number 8. I guess I didn't finish this. So take the square root of both sides, sine x equals plus or minus the square root of 3.
Was it supposed to be a tangent there? Tangent square?
Or cotangent, that would have worked.
Right.
Yeah, I just think this was a typo, this example. It's supposed to give you a number on the unit circle for these. So, we could find it with the calculator. I see in my filled in notes I didn't finish this problem. You could use that, find the approximate answers on your calculator. Let's show you how to do that. X is going to be, okay, we're going to take sine inverse of the square root of 3, and we're going to take sine inverse of negative square root of 3, and just show you how you find that on the calculator. Second sine inverse, second square root 3. Wait, oh, that's why I didn't solve it. Guess what the square root of 3 is, guys? Second square root of 3.
It's greater than the
It's greater than, yeah, the sine of x has to be a number between -1 and 1. So we can just cross this out. There's no solutions from here. So there's not a typo here. 1.732. That's impossible, so the only solutions are there. Let's get our calculator out of the way. All right. I'm going to pause this a minute. Okay. Okay, so you can also use identities to solve a trig equation. Notice in this next one, it says cosine 2x plus sine x equals 0. In order to solve this equation, we can't have double angles, and we need one trig function of the same angle. That's why we shouldn't leave our angles out when we write sine and cosine and stuff like that. Okay, so we're going to look at our identities paper and say, What can I replace cosine 2x with to get it in terms of sine x? You see?
1 minus sine squared n.
Yes,
Two
there we go. Cosine 2 theta equals 1 minus 2 sine squared theta. That's the one we want to use. So we replace it. So, all right, that's what you need to do. Cosine 2 theta equals 1 minus 2 sine
I have a quick question about that.
theta. What?
I have a quick question about that.
Sure.
On the math lab, I noticed that when there's a negative in front of cosine there, it becomes like 2 sine squared minus 1. Is that right? Or is that just a pattern that I noticed?
Oh, I'm not sure. If there's a negative here, and if it's cosine negative 2x or negative,
Negative cosine 2x.
you're saying if it's negative cosine 2x?
It kept saying that the answer was 2 sine squared x minus 1.
Oh, okay, yeah. Well, cosine of 2 theta equals 1 minus 2 sine squared theta. So if you multiply through by a negative 1, you can switch these.
Okay.
Yeah, that's all they're doing.
Okay.
That if it's negative out here, if you'd be negative 1 plus 2 sine squared theta, and then they switched them.
Oh, gotcha. Okay.
So this equals negative 1 plus 2 sine squared theta, and that can be written as 2 sine squared theta minus 1.
Gotcha. Okay. That
Okay.
makes sense.
So they just used this identity and distributed the negative sign to both terms. Okay. All right, so we have 1 minus 2 sine squared x. Oh, yeah. 2 theta, so 2x, and this would be x. Make sure this is number 9. Yep. Plus sine x equals 0. So I'm going to rewrite it in descending order, and if you want to make a substitution to factor, you can. This is going to factor, but so we're going to, this is the squared, we're going to write that first, plus sine x plus 1 equals 0. Do you guys like to make the substitution to u first? So let's let u equal sine x. So we get minus 2u squared plus u plus 1 equals 0. Anytime you're factoring, if you have a negative in front of the first term, you want to factor that negative sign out. So, or you divide by a negative 1. You can either factor the negative out or divide through by a negative 1. You're going to get 2u squared minus u minus 1 equals 0. So I'm going to rewrite it up here. Then we're going to factor. It's going to be 2u and u to get the first term. 2u times u is 2u squared. It's going to be a 1 and a 1, and the signs have to be opposite signs because it's negative. And the bigger one's going to be negative. So when we FOIL, the outer term has to be minus 2u, the inner term has to be plus u. But you can factor on another piece of paper and distribute, make sure you got it right, if you struggle with that. But that's how it factors, so either 2u plus 1 equals 0, so 2u equals negative 1u is negative a half. Well, u was sine x. So sine x equals negative a half. Or u minus 1 equals 0, so u equals 1, but that's sine. Again, we're staying between here. We're just going to pick the numbers off the unit circle then. So I drew a picture. Where is sine x negative a half?
7 5, 6, and 11 5.
Right. From the unit circle, that's at x equals 7 pi over 6, 11 pi over 6. And sine x, sine of pi over 2 is 1, so it also equals pi over 2. So we have 3 answers. So how would if we added the 2 and pi to each of those and it's an integer, that would be all answers. The sine period is pi. So sometimes on the test I ask for all answers and sometimes I ask for answers between 0 to pi. So, any questions?
So all you have to do is add the plus
Plus
period
2,
pi in.
yes.
Gotcha.
Plus the period n.
Oh,
The
gotcha.
period is
Right.
been in terms of pi. Okay? And on all these kind of questions, I asked for exact answers in terms of pi. In radians. Okay. I'm trying to make sure I specifically say what I want. It just takes, giving some tests to realize how specific you need to be on the direction. All right, and then the next one. Okay, we want it all in terms of cosine. Then this is one way to do it. Do you see an identity? Is there an identity? Yeah, we can use the Pythagorean identity. I'll write it over here. That sines, we want to write this all in terms of cosine to solve it. We don't have any double angles this time, so we're going to use the Pythagorean identity. Sine squared x plus cosine squared x equals 1. Solve this for sine squared, subtract the cosine squared. So sine squared x equals 1 minus cosine squared x. Replace sine squared x with 1 minus cosine squared x minus 3 cosine x equals 0. Now we have it all in terms of cosine. We can distribute 2 minus 2 cosine squared x minus 3 cosine x equals 0. We could do a substitution. Let u equals cosine x. And then we want to write it in descending order. So it's minus 2u squared minus 3u plus 2 equals 0. Divide by the negative 1 or multiply through by a negative 1. 2u squared plus 3u minus 2 equals 0. And then factor. It's possible to factor with the negative out here, but it's much more complicated. Like the factor like that. It's going to be a 2u and a u. We got a 2 and a 1, but notice the 2 doesn't come out of everything, so the 2 has to go over here, the 1 here. Negative sign here means we got opposite signs. And the bigger one has to be positive, the outer term has to be positive, that's 4u minus 1u is 2u. Okay, and then we're gonna set,
Could you bring it down just a little?
sorry. Okay, and now we're gonna set, there's really not enough space here, but fit it in. We set each of these to 0. 2u minus 1 equals 0, so 2u equals 1, u equals 1/2. But u is cosine. U plus 2 equals 0. U equals minus 2. Cosine x equals minus 2. Can cosine x ever equal a number more than one, negative 1 or 1? So there's no solutions from this. Not possible. And then, in my building notes, I sketched the unit circle. Cosine is 1/2 at pi over 3. And 5 pi over 3. We want the answer in terms between 0 to pi again. So x equals pi over 3, 5 pi over 3. All right, now we're going to use our calculator. How do you use your calculator to solve these? There's a couple questions like this on the test too, just using your calculator. So, if we've got tangent x equals 3.104, and we want the answers between 0 and 2 pi, we're gonna find tangent inverse on our calculator. So we're using a calculator, we're going to find approximate answers.
This is all going to be in radians, right?
Yes, and it's in radians because we say x. It's in radians because we say x should be between 0 and 2 pi. Tangent inverse of 3.1044. So, bring the calculator up. Did you all finish copying the other stuff? Second inverse tangent of 3.1044. Oh, guess what? My calculator's in the wrong mode. Gotta check that mode. Radians. Quit. Second, recall the last entry. Here we are, and I'm going to keep 4 places. It'll be 4 decimal places. I'll just tell you that. 4 decimal places. So that equals 1.2592 approximately. All right, so let's draw a picture of a coordinate. 1.57 would be up here. So 1.2 somewhere up here. All right. Tangent is positive in quadrant 1. And this is positive. It's also positive in quadrant 3. So we need to find so our reference angle is the 1.259. This is quadrant 1. It will also be positive in quadrant 3. So we're going to go down to quadrant 3, and our reference angle is against the x-axis is 1.2592. This is pi. So we're going to add that. I don't, anyway, it's this angle is going to be pi plus, we have to take pi plus 1.259. So, second pi plus, second pi, so it's approximately 4.4008. So our two answers are this and this.
Could you just use the thing we came up with, all students take calc or whatever, to know which reference angle to use? Or do you have to,
Oh, well, you
because you know
can,
that it's tangent, right?
it's tangent and it was positive, so it has to be quadrant 1 and 3. You can use the all students take calculus.
Okay.
Yeah. But that's how you figure out where the other angle's going to be, by where the function is positive or negative. And that's how we're supposed to work some of those questions on the last page of that last test. See where tangent, the reference angles are always positive, but we had to figure out what is always against the x-axis. Okay? So we had to figure out where tangent was positive and what other axis is going to be true in. The next one. So these are different than what we did before because we're looking for between 0 and 2 pi. All right, sine is negative. Well, we're going to first do x. One answer is going to be probably sine inverse of this. And we're going to do that on the calculator. Instead of use the calculator, you can use it. Second inverse sine of negative 0.2315. So x is negative, oh, this is not one of our answers. This is not x. Sorry. Not x. X has to be between 0 and 2 pi. So this isn't even one of our answers. But from this answer, we're going to get our reference angle. Our reference angle, they're always positive. It's going to be positive 0.2336. Now let's draw the quadrant. Where is sine negative? Negative here.
3 and 4.
Right. So we got to go 0.2336. This is quadrant 3, quadrant 4. We got to go 0.2336. So on this one, we got to add pi. So x is going to be pi plus 0.2336. That's one answer. The other answer is going to be 2 pi minus 0.2336 because we want answers between 0 and 2 pi. Okay, so if I add 2 pi to this answer, 2 second pi, that's that answer. It's approximately 6.0496. That's one answer. And the other answer is second pi plus 0.2336. About 3.3752. Okay, those are the two answers. Those are approximate. So that's how you do those problems. And we have one more example. This is long. Okay, so drawing a sketch is very helpful. On the test, I didn't say you had to draw the sketch on these, but you're most likely to get your answer right if you draw the sketch to help you. And understand that you need the reference angle and that where was sign negative. And those are the steps. And that's how you're going to get these right. Okay?
That's actually where our notes end.
It does.
Yeah.
I've got
We can do it on the back. That's how you should go.
I've got another one. Oh. Is this the same? Is this different?
It's different numbers.
Okay, so it's more examples of the same thing.
I think we got those.
Okay, so I guess, I don't know why I had this. I have this on my notes, but not, yeah, you're right, the printed notes dropped these questions, but radius mode, yes, I wrote that down. And then I had to notice that tangent was positive in quadrants 1 and 3. It worked the same way, except you did get one answer correct there, and then you had to add pi. That looks like the same. I don't know. It's different. And cosine negative. Where's cosine negative? So I figured out where cosine was negative. Quadrants 2 and 3. I found my x. That's quadrant 2. I had to realize 1.572 is going to be quadrant 2. I had to find my reference angle, taking pi minus that. And then I had to use my reference angle and find this. Draw the picture. I'm saying it's going to help you. Because even though you're allowed to use your calculator, these are not that easy. You know, you're most likely going to forget the second answer. So, reference angle, and I had to add pi plus the reference angle. All right, well, look at the review. We may or may not have time for you to work the whole thing, or if you want.
What else will we be doing next class?
Next class is just review.
Can we do those things where we like work it on our own and then like we like check, you walk around the room and help us?
Sure, I can do that. I can do that if you want. Because I'd rather do that than like. So try to work what you can, and then, you know.